Good morning, ma'am. I'm Chandana from CSEA. Today's my topic is demultiplexers from Digital Logic and Computer Organization. Now, here are the contents what we are going to explain in demultiplexer. First of all, introduction to demultiplexers, and next definition and function, and how demultiplexers works, types of demultiplexers, and we are going to explain about applications and demultiplexer, circuit design, and truth table of a demultiplexer, and next advantages of using demultiplexer. By knowing the advantages of demultiplexer, we can know in which area we are using the demultiplexers, and the challenges and limitations, which are made by the demultiplexers are to be known in this video. And last, I'll conclude my topic with the end. First of all, introduction to demultiplexers. Demultiplexers, commonly referred to as DMUX, are digital switches that channel multiple inputs to a single output. They are essential components in communication systems, allowing for efficient data rotating. And understanding their operation is crucial for designing complex digital systems and circuits. Nowadays, demultiplexers are widely used in different areas, and it is so useful in computer networks also. Definition and function of demultiplexers. A demultiplexer takes a single input signal and rotates it to one of several output lines based on the control signals. The device can be seen as reverse of a multiplexer, which is known as demultiplexer, which combines multiple inputs into one output. Demultiplexers are typically used in applications like data distribution and signal rotating. First of all, what is demultiplexer? When we use several number single output, it produces a several number of outputs. It is known as demultiplexer. When we give both complement inputs, then it produces zero output. This is how demultiplexers works. The operation of a demultiplexer is controlled by select lines that determine which output line to activate. For an n for n to 2 power n demultiplexer, the control signals can choose from among 2 power n output lines. The output is active only for selected line, ensuring that input signal is directed correctly. Here is the diagram how demultiplexer works. These are the types of demultiplexers. There are various types of demultiplexers, including 1 to 2 demultiplexer and 1 to 4 demultiplexers and 1 to 8 demultiplexer and more. Each type corresponds to the number of output lines it can control, dedicated by the number of selected lines. The most common configurations are 1 to 4 and 1 to 8 demultiplexers are widely used in the digital circuits. Here is the 1 is to n demultiplexer diagram. Here we can observe the how demultiplexers works in a digital circuit. Here are the applications of demultiplexers. Demultiplexers are widely used in the digital communication systems to distribute data signals effectively. They are utilized in memory address decoding, whereas single address line activates specific memory locations. Additionally, they play a role in data routing for multiplexing systems in telecommunications. Here is the diagram how demultiplexer works. Here, when we give both complements of a input, then the output will be 0. When we give one complement function as a input and one direct function, then the output will be 0, 1. And when we give complement from the B and direct signal from the A, then the output will be 1, 0. When we give direct inputs from both A and B, then the output will be 1. Here is the demultiplexer circuit design. Basically, a basic demultiplexer circuit can be constructed by using logic gates like AND or NOT gates. This design involves connecting the inputs to the output lines through the appropriate logic conditions. Understanding the logic diagram is essential for implementing demultiplexers in hardware. Here is the demultiplexer circuit design. Here is the truth table of a demultiplexer. The truth table of a demultiplexer outlines the relationship between input control signals and output. Each row of the table represents the different combination of circuits, control signals, and the corresponding active output. Analyzing the truth table helps in the verifying functionality and demultiplexer circuit. Here is the demultiplexer diagram which belongs to 1 to 4 demultiplexer. When we give 2 input lines, it produces 4 output lines. So it based on the when we give 2 n input lines, it produces 2 power n output lines. For suppose when we give 3 input lines, it produces 8 output lines because 2 power 3 is equals to 8. Here are the advantages of using demultiplexers. Demultiplexers simplify circuit design by reducing the number of required connections. They enhance data organizations and routing efficiency in complex systems. By using demultiplexers, designs can be minimize signal reference and improve the overall. Here is a 1:4 demultiplexer. When we give both inputs 0, then the output of Y0 will be active. When we give B0 and A1, then the Y1 output will be active. When we give B1 as active and A is equals to 0, then Y2 will be in active mode. When we give both active inputs, then it will produce active high output. And also in this diagram we used 2 NOT gates and 4 NAND gates to produce an output. Challenges and limitations. One challenge in using demultiplexers is the potential for the single regardation over long distances. They also require careful timing considerations to ensure data integrity, warning switching. Additionally, the complexity of higher order demultiplexers can pose design difficulties. Here are the what are the some potential benefits of learning analyticals? What are the some potential challenges of using learning at analyticals? What are the some limitations of learning analyticals? Last, I'm concluding my topic with this. Demultiplexers are the fundamental components in digital systems that facilitate efficient data management. Their functionality and versatility make them indispensable in modern communication and computing applications. A solid understanding of demultiplexers is essential for anyone involved in digital circuit design and engineering. It's also very useful in digital circuits and computer analysis. Thank you, ma'am. Thank you for giving this opportunity.